Be exam ready. Achieve top grades. Quadratics Part 2. From Basics to Grade 9. Part 2. We're looking at exam style question practice today. So the topics that we are looking at are forming equations, quadratic simultaneous equations, inequalities, and graph sketching. So here are our learning objectives. By the end of this lesson, you will be able to firstly form equations, that is, translate worded and context problems into quadratic equations. Secondly, solve in-context questions. This means solve quadratic arising from area, integer, and motion problems, and reject invalid roots. Thirdly, simultaneous equations. So we're going to solve linear quadratic simultaneous equations algebraically. Fourthly, inequalities. Solve quadratic inequalities and represent the solution set correctly. And finally, we're also going to interpret graphs. That means sketch and interpret quadratic graphs from roots, turning point, and y-intercept. Forming and solving quadratics from context. Here's an examiner tip for you. First, you have to define your variable clearly. Form the equation, and then check every root against the physical constraints of the problem. So, in our first question, it says a rectangular garden has length x plus 4 meters, width x meters, and the area is 60 meters squared. So let's start constructing our equation. So this is where we're starting from, okay, because our variables have already been defined for us. So these are our variables, x plus 4 and x. Now constructing the equation is like this. Area of a rectangle is length times width. And if we look at the length that has been given to us as x plus 4, the width is x, so you can remove the multiplication sign because that means product anyway, and the area is 60 meters squared. So the next thing we got to do is multiply, expand the brackets, multiply into the bracket, so you're going to get x squared plus x times 4, which is 4x, and on the left hand side you have 60, which means that we're going to have to bring the 60 on the right hand side. Remember, you got to solve the equation, quadratic equation, and when you do that, you must make sure that you get 0 on one side of that equation. Next thing is we're going to be looking at factors of 60. 60 has factors 1 and 60. You got 2 and 30, 3 and 20, 4 and 15, 5 and 6, sorry, 5 and 12. So let me rub that off, 5 and 12, sorry, okay, 5 and 12, and 6 and 10. Now, the next thing is the negative sign. So if we put a negative sign over there, as you know, you multiply positive and negative to get a negative, or a negative and a positive to get a negative. So if you multiply a plus 1 with a negative 60, you're going to end up having a minus 59. And minus 59, I'm going to write it here. Or you can reverse the sign. You can have a negative 1 multiplied by a positive 60. And that still gives you a negative 60. And if you combine these two, you're going to get a plus 59. Likewise, for the next term, for the next two numbers, so you can have plus 2 times negative 30, okay, which is going to give you negative 30. But when you combine them as additions, so you're going to get negative 28 for the top row, but top row of signs, but for the bottom row of signs, it will be a positive 28. And therefore we can go on and on. So you can have plus, minus, plus minus, plus minus, plus minus, and the corresponding signs on the other hand will be, on the other side will be minus plus, minus plus, minus plus, minus plus. And when you combine them together, plus 3 and minus 20, that gives you negative 17. Below is going to be positive. On top, 4 and 15, that gives you negative 11, or you can have positive 11. Then you have 5 and 12 plus 5 minus 12, that's minus 7, or plus 7. And that one gives you negative 4, or plus 4. Now, what we're looking for is plus 4, which happens to be just the last one, and that is means negative 6 multiplied by plus 10 will give you negative 60. So when you factorize then, so that's going to be x and x inside the brackets, and you get negative 6 x plus 10. And solving the equations, you just have to invert that sign. You're going to get x equals to 6 or x equals to negative 10. But we're going to reject the value of x being negative. As we know, width can only be positive. Okay, so we're going to reject since x is greater than 0. Hence, the solution is simply going to be x equals to 6. Okay, and you can write meters there because that's the unit. Okay. Question number 2. In this case, we have not got the variable. Therefore, we're going to have to define the variable. We are therefore going to say, let the variables or let the integers be n and n plus 1. We've been told that they are consecutive integers, okay? And what do we do with them? We're going to find the product. And the product means multiplying these two together. Is means equal, and then you got 132 on the right hand side. So let's write this down. So the product means, so that is to do with the product, and the product means multiplying these two together. So you're going to get n times n plus 1 equals 132. Now we will need to look for expanding the brackets first, so that's going to be n squared plus n is equal to 132 on the right hand side. Now if we're looking at those numbers, that 132, we're going to have to move it to the left hand side, and that means n squared plus n minus 132 equals to 0. Remember, you got to get 0 on one side of the equation for you to be able to solve that. So 132, let's look at the factors of that number. 132, so the factors are 1 and 132, 2 and 66. You can easily do that by dividing 132 by 2. You can try it with 3 and you're going to get 44. If you do divide 132 by 4, you're going to get 33. And if you divide by 6, you're going to get 22. And if I divide by 11, you're going to get 12. As you may realize from above, if you put, because it's negative here, so plus minus, all the way down. And on the other side, it's just going to be the other way around. Okay, so let's combine them. By combining them on the right hand side, what we're going to get is plus 1 and minus 132 is minus 131. Okay, underneath you just need to put the plus sign. For the next row, it's going to be 64, but minus on top, plus at the bottom. That one is going to be 41, minus and plus. That one is going to be 29 minus n plus. This one is going to be 16 minus n plus. And lastly, that's going to be a 1 minus n plus. And because you're looking for plus 1, remember that's a coefficient of 1 plus 1. So we're going to be looking at minus 11 and plus 12 as being the factors that we're looking for. So in our quadratic equation, you're going to write n minus 11, okay, minus 11 and plus 12. To solve that equation, you just need to invert the sign. For minus 11, that becomes 11, and n becomes minus 12. And as you've been given the constraint here, so we're talking about positive integers, meaning you will have to reject one of them, which is n is equal to negative 12. So we reject this one, since n has to be positive, which means greater than 0. Hence, our solution is going to be n is equal to 11. Okay, so now it's time for you to do some practice questions. And those questions that are on the right, as you're going to be able to see. So these are going to be your practice questions for the next part of the question, for you to practice. Here are the answers from the previous slide, and hope you have been able to attempt those questions, and you can compare now your work with mine and be able to see if there are any differences. It doesn't matter with the difference in the way you do the questions, but as long as you explain your work carefully. And that one is definitely, these are the answers for you to compare with. Okay, right. So now let's move on to the next concept. Concept number 2, quadratic simultaneous equations. Here's your examiner tip. Substitute the linear equation into the quadratic one, never the reverse. It creates unnecessary square roots. Okay, so let's get on with the first question. So y is equal to 1, x equal to plus 1, and y is equal to x squared minus 5 are these two equations that we're going to have to solve simultaneously. So let's start by labeling those equations. Y is equal to x plus 1, that's equation number 1. Y is equal to x squared minus 5, that's equation number 2. What we need to do is we are going to replace this y by this y. And when we're doing that, so this x plus 1 is actually taking the place of that y. So essentially, we are saying equation 1 is the same as equation 2. We are just substituting the y by x plus 1. So that's your substitution into the quadratic equation. So that becomes x plus 1 is equal to x squared minus 5. Now, if you remember, we're going to have a 0 on one side of the equation to be able to solve the quadratic equation. So let's put a 0 here, because my intention is to bring everything to the right-hand side. Let's write x squared minus 5, because they stay put, they're not moving anywhere. When you're moving x to the right-hand side, it becomes minus x, plus 1 becomes minus 1. And let's simplify that. So that gives me x squared minus x. We're going to combine these two terms. That gives you minus 6. And on the left-hand side, we have 0. Now we're going to factorize, find two factors for 6. So 6 factors of 6 are 1 and 6, 2 and 3. Now, because you have the sign which is negative, negative is what you get when you multiply a negative and a positive together. That gives you a negative minus. Or you can have a plus and a minus, which will give you still a minus. So let's apply this here with the numbers. If you have minus 1 times plus 6, you're going to get -6. Conversely, if you do +1 and -6, that gives you the same result as -6. And you can repeat the process further down. So plus, minus, minus, plus. When you combine the numbers along the horizontal line, in which case you're saying -1 multiplied by, -1 plus 6, that gives you a +5. -1 and +6. If you do +1 and -6, you're going to get a -5. If you do +1, take away 3, you'll end up with -1. And if you do -2 plus 3, you'll end up with +1. Now, in that question now, after having split the factors of -6, we are going to have to look at what happens here. That is actually -1. And going back to -1, the way we got -1 was by taking +2 and -3. So +2 and -3, so x plus 2 times x -3 and equals to 0. Now, as far as x is concerned, and x can take two values to satisfy that equation, which are x equals to -2 or x equals to 3. Now, this only solves half of that problem because we also need to find the corresponding values for y. Now, which equation are we going to pick? Equation 1 or equation 2? Equation 1 is the easier one to use. So we're going to say replace x in equation 1. So equation 1 is y is equal to x plus 1. When x equals to -2, y is -2 plus 1, which is -1. And when x equals to 3, y equals 3 plus 1, and that gives me 4. So we got therefore two pairs of values, and then x equals to -2, y is equal to -1, or x equals to 3 and y is equal to 4. So two pairs of values, two pairs to give us the solutions. Now let's look at the question number 2. In that question, it gives me the equation of the line. So equation of the line is given as y is equal to mx, and the equation of the curve is given as y is equal to x squared. Now we got to solve that problem, and we got the values of x and y given to us. So x and y. So if we know the value of x and the value of y, we should be able to get the value of m. Now that equation is actually more useful than equation 2 because equation 2 does not have m. So we're going to be using equation 1. Using equation 1 and the point 2 and the point 2, 4. So that means x is 2 and y is 4. So equation y equals to mx is going to give us the value for m. So so we got y is equal to 4. We don't know the value of m, so substitute y by 4, substitute x by 2, and then m equals 4 divided by 2, which is 2. So m equals to 2 is the solution. Now, over to you in order to answer the question that you have made for you on the right-hand side. So bear with me and you're going to see that question, those questions. So try these questions and you can pause the video here and I shall see you on the next slide for you to check your answers. Okay? All right, see you then. Quadratic simultaneous equations, the answers. Now you had to go at those questions, so I brought my answers onto this slide. It's for you to compare with them. Hopefully you will have go through all of them correctly. And if there's any problem, I hope these answers are clear enough for you to be able to solve your problems on that slide. Okay, so let's move on now to the next slide for the next concept. Concept number 3, quadratic inequalities. Examiner's tip. You go to sketch the graph first. The shape tells you instantly whether the solution is between or outside the roots. Let's see how it works. Now you will notice in the first question that I've picked for you is that it says solve x squared minus 2x minus 8 is less than 0. From that equation, you can tell that the equation is that of a quadratic equation. Quadratic equations can only have two shapes. It's a cup shape, it's a U shape, or a cap shape. And a U shape is when you have ax squared plus bx plus c, and a is greater than 0. And in the case where a is negative, a is less than 0, then you have the cap shape. Now, in our question, we clearly have a case of a cup shape. It's a U shape. Now, let us see how that works. So the first thing that we are going to do is to find the root for this expression. In other words, we'll have to factorize this expression. In order to factorize that, you got to look at 8, and then we're going to be looking at negative 8. So factors of 8. Factors of 8. So 8, you got 1 and 8, you got 2 and 4. Now, because it is negative 8, then you have to think of plus and minus, or minus and plus. So plus 1 times negative 8, that gives you negative 7. But negative 1 and plus 8, when you combine them, you get plus 7. The next one is going to give me 2 and 4. So if you start with negative, then positive, negative 2 times plus 4 gives me negative 8. But if you combine them as they are in terms of their sign, you're going to get plus 2. And if you use plus 2, negative 4, you end up with negative 2. Now, this is precisely what we're looking for, negative 2. So this means plus 2 and minus 4 will be our candidate factors. So in that case, you're going to get x plus 2, x plus 2, and then x minus 4, which therefore, if we complete that part, is going to be less than 0. So what are the roots or critical values? Sometimes we call them critical values. So the roots are x are minus 2 and 4. So let's draw the number line, which is in fact that of the x-axis. So the number line for the x-axis, or the x-axis itself. So you're going to get negative 2 here, 0 is somewhere here, and 4 is twice the distance that we have compared with 0 minus 2. And because it is a cup shape, let's draw that cup here. And what you need to remember here, so that curve has 3 parts to it, okay, in terms of where we have the positive side, the negative side, and the 0 side, okay, where it's 0. So that part, okay, that is the part where the whole value of x they are positive. That's the positive part of that curve. And underneath, that's the negative part of that curve. And exactly on that line, that's where the curve is, the expression is equal to 0. Okay, so what are we looking for? In our case, what we're looking for is this positive side, which means that's the positive side, and therefore the part of the curve that we are interested in is that part, the top part. Now, in order to be able to access the top part of that curve, we should be looking on the right-hand side of 4. To be able to look on the right-hand side of 4, that means it's taking the values of x on the right-hand side of 4, which is x is greater than 4. But on the left-hand side, we want to access the curve. The yellow part, the highlight, means we are looking at the left-hand side. The left-hand side means x is on the left-hand side of -2. So you got, therefore, your inequalities. So x is less than -2 or x is greater than 4 for you to be able to access the positive part of the curve. Now, in order to be able to access the negative part of the curve, and that's what the question is about. So negative part is what is left from what we've seen. So to access the negative part of the curve, which is therefore here, and I'm going to use a different color for the highlighter. I'm actually going to use green. In fact, that's meant to be looking at the lower part of the graph, and this is what we're looking for. Therefore, the answer is not that we're not looking for this right-hand side and the lower left-hand side. We're looking for actually the middle part, the in-between part, because this is where you have less than 0, and x has to be in between those two values, -2 and 4, and that's the answer. Okay, solution, x lies between -2 and 4. Now let's solve the next problem, which is x squared minus 9. Now this is a very interesting question because examiners love this, because examiners are trying to see whether you actually picked up the difference of two squares. So what's the difference of two squares if you can remember that? So difference of two squares means a squared minus b squared gives you a plus b, a times a minus b, right? So this is what it is. So the difference of two squares, which means x to the power of 2 minus 3 squared greater than 0. Now, this is what we're talking about. We got two squares here. In fact, you can split this as these two factors. So let's do that. X minus 3, x plus 3, we can start with the positive one, and then x minus 3, and that is greater than 0. Now, if you remember from our first discussion of that question, so the yellow highlight is looking at the positive side. So that's what we are looking for, the positive side as well. Now, if you remember the examiner's tip, it says sketch the graph first. So that's what we're going to do. We're going to sketch the graph, but we need to know what the critical values or the roots are. So roots are, so we invert that sign, it becomes -3 and plus 3. Now you are not allowed, so I'm just going to put a word of caution here, not allowed to write x equals to -3 or x equals to 3. So this is a danger zone because many people lose mark, so we can't write this because people are writing an equal sign as well as inequality sign, and the examiners are not going to look for the right one for you and ignore the wrong one for you. So be careful about this. So never think about writing this in there. So I would have highlighted that as well in the first question, but it's done here. So Okay, and like the examiners are looking for a sketch, so therefore I am going to draw a U-shaped curve because that's what it is. Right, how do I know that? Because it has got a positive coefficient, which is positive 1 in the front of x squared. So this is our curve, and these are the two roots, -3 and 3. And which part of the curve are we looking at? So we're looking at greater than 0. Therefore, we're looking at the positive part of the curve, which is that part and that part. So if we're looking for the positive part of the curve, in that case, you're looking to the right, you're looking to the left. We're looking to the right of x is greater than 3, and we're looking to the left of x is less than -3. So these are the solutions of the equation of the inequality. So it's not the equation, but the inequality. So over to you now to be able for you to practice some of the questions, and I would like you to use the theory that you have looked at on this slide on the left hand side for you to be able to move on. Okay, so here we go. I'm going to show you now the next part of your work. Okay, here we go. So all the marks have been given. So you can pause the video here, and I'll see you on the next slide. Now you will be able to compare your work, and hopefully you have taken enough time to see all the information I've put in there for you to improve the quality of your response. Concept number 4, sketching and interpreting quadratic graphs. This is your examiner's tip. Plot the y-intercept, roots, and turning point first. 3 features are usually enough to sketch an accurate curve. So let us practice this with the first question. Y is equal to x squared minus 2x minus 3. So what I'm going to do is I'm going to look for the roots first. And the way I'm going to do this is I'm going to find it by factorization, find the roots by factorization. So let's get started here. Y is equal to x squared minus 2x minus 3. If you remember, 3 is your the number that you need to split into 2 factors. So that is a very simple case. So it's 1 and 3. And because you have minus, it is either plus 1 times -3 that gives you a -3, or a -1 multiplied by a positive 3, which gives you a -3. However, when you are going to combine them horizontally, let's see what you get. So a plus 1 and a -3 gives you a -2. A -1 plus 3, that gives you a positive 2. Now we are looking for -2 in that case. -2 is the top symbols, so plus and plus 1 minus 3. Therefore, we're going to factorize the expression as that one. So it's going to be x plus 1, x minus 3. That allows us to place the roots at, so the roots are x equals to -1 and x equal to 3. So let's draw our number line, which is the x-axis. So you're going to get -1 as the first root. So let me just draw the curve, it's easier that way. And then you're going to put the 3 there. So 0 is going to be somewhere here. And the reason for me to put the 0 afterwards, because it's very convenient for me to draw the y-axis after that. So y-axis is where x equals to 0. So that is a cue for you to know where to find the y-intercept. So y-intercept, that's what we're looking for next. So y-intercept is effectively when x goes to 0. Let's substitute x goes to 0 as 0 into the equation. So y equals to 0 squared, I'm looking here, minus 2 times 0 minus 3. And that gives you 0 take away 0 minus 3, which is negative 3. And it is it's actually right because it's a negative value, negative 3. So 0, negative 3 is the intercept. So 0, negative 3 is the y-intercept. The next thing is to find the turning point. Now, turning points are right in the middle of a curve. So to find the middle of the curve, that's finding the halfway value between negative 1 and 3. So halfway value of x. So x equals to negative 1 plus 3 and half it. So that's 2 over 2, which is 1. And we're going to replace this in y. So y equals to 0, not 0, sorry, it's a 1 squared minus 2 times 1 minus 3, which gives you 1 minus 2 minus 3, and that ends up with minus 5. So the turning point is 1, negative 5. So that's where it is, 1, negative 5. All right, so that is the first question. Moving on to the next one, we want to know how many real solutions we have for this expression. Now, the way we are going to do this is to work out what we call discriminant. Now, the word discriminant is not in the syllabus, but there's a formula for working it out. And the reason is as follows. Now, when we're talking about real solutions, if you can visualize the shape of the curve either being above the x-axis or on the x-axis, or the curve goes below the x-axis as well. So there are three situations. So let's look at that. Situation one, you can identify that if you look at the equation like this, ax squared plus bx plus c equals to 0. Well, we don't really need the 0, we just need a, b, and c. So you apply this formula, b is equal to, sorry, it's not b, it starts with a d. So d is equal to b squared minus 4ac. Okay, let me tidy this up. So remember, if you use this formula, d is equal to b squared minus 4ac, you will understand what's going on. So what happens in the case of that formula? So there are three situations. To be able to get a situation where the curve does not even go into and touch the x-axis, so that's when d is negative. When the curve actually touches it only once, so that gives you only one unique solution, one solution. And this is when d is equal to 0. And when the curve touches in two places, so you get two solutions. Okay, and in that case, d is less than 0. Let us see which one of those we are looking at. Now, for the first one, you must be wondering there's no solution because it doesn't even touch the x-axis. So there's no solution. Now, let's substitute b, a, and c into this equation. b is b is equal to 4, a is equal to 1, and c is equal to 7. b is equal to 4, so 4 squared minus 4 times a, which is 1, and c is 7. So we are going to get 4 squared is 16, take away 28, which is negative 14. So that's all d, which ends up saying to me that d is negative. If d is negative, then in that case the curve doesn't even touch the x-axis, and therefore there's no solution. So The conclusion is no solution exists for this equation. That's what you got to write. Okay, so for this equation. Okay, so you will be practicing on the questions which are on the right. And here we go. You should be able to see the questions now, right? Yeah, they are. Okay, let's practice those questions and I'll see you on the next slide. For now, you can press pause and practice the questions. Okay, see you then. All right, so here are the answers for concept 4, and hopefully these are explanatory enough for you to be able to see where you may have made mistakes, or you have consolidated your learning. Now let's see the key takeaways from Quadratics Part 2 exam style practice. The first one is to translate context into algebra first. Here you have to define the variable, then form the equation. The next thing was to substitute the linear equation into quadratic equations, particularly when solving simultaneous equations. Thirdly, you can sketch before solving inequalities, and this is what you need to do. The shape decides inside, between, or outside the roots. Roots, y-intercept, and turning points are enough to sketch any quadratic curve accurately. Coming up in part 3. Part 3 is about extended problem solving, multi-step grade 9 challenges combining quadratics with geometry, algebraic proof, and functions. I hope you enjoyed this video. Please like, share, subscribe, and comment. Your feedback will help me create more videos like this. Until next time, it's goodbye from me. Bye-bye.